Alright, so we'll be starting with the major topics on the paper. And we did quite a few of these topics already from class. Quite a few of them. So I think we can start with this matrix question here. So matrices is usually at question 10, second part of the question. And it would usually start with the vectors question. So this is from the 2025 paper. Question 10. So it says, three matrices A, B, and C are such that, so they gave us three different matrices here. And firstly, we need to identify the order of these matrices. So whenever you're dealing with a matrix question, you must first try and identify the order before you do anything else. Matrix A is a 2 by 2 matrix. Matrix B, 2 by 3, 2 by 3. So how do we get the order of a matrix?
We just look on it and count the column and the rows, so you know if it's 2 by 2 or 2 by 3.
So row by column. Alright, so next they want us to find matrix AB plus C. So what we have here is multiplication and addition. So we must first find matrix AB. AB is telling us that we need to multiply A and B. So this is what we need to find first. And how do we know if we can multiply two matrices? We do what?
Similar order.
So we list the order. So matrix A is a 2 by 2. Matrix B is a 2 by 3. So if the inner elements are the same, that tells us that they are compatible. The outer elements gives us what? What does the outer elements give us?
For the answer, or probably.
So the result. So after we multiply, we should get a 2 by 3 matrix. So let's see how we can actually multiply these two things. So AB is equal to 3, 2, 5, 4. Alright, so just as how we get the order of a matrix row by column, that's exactly how we multiply row by column. So what will happen is that we're going to take the first row and we're going to be using it to multiply all columns in this matrix first. So we're going to take the first row. So it's going to be 3 times 4 plus 2 times 3. That's going to give us the first element in the answer. Next, 3 times 0 plus 2 times negative 1. 3 times 2 plus 2 times 7. So is that clear?
Yes, sir.
So what would give us the second set of elements down here?
other row with the other column.
So tell me now how it go.
So 5 times 4 plus 4 times 3. 5 times 0 plus 4 minus negative 1. 5 times 2 plus 4 multiplied by 7. You can tell me what an oxymoron is.
And then we simplify. So 3. Just separate them.
Festival of guns, people. Very good. Because these are wonderful to know that.
Someone's mic is open.
Miss.
Alright, so 3 times 4 plus 2 times 3. Now if you can't mentally do this, don't be ashamed to use your calculator. So that's 18. So if you mentally can't do this, just use the calculator. That's what you have it for. And it also saves time. So this is 18. This is negative 2. 6 plus 14, 20. 20 plus 12, negative 4, and 38. So this is what AB would be equal to. But we aren't finished because they said they want AB plus C. So to this answer, we're going to add C. So if that's AB, and they said that we should add, so AB plus C. So that's going to be equal to all of this and whatever C is plus, so matrix C is 4, negative 1, 2, 7, 3, negative 5. 4, negative 1, 2, 7, 3, negative 5. And how do we add two matrices? Go again.
Sorry, just add with its corresponding number, whatever.
So we add the corresponding elements. So 18 would correspond with 4. So this is the first thing in this matrix. First thing here, we add them. That's 22. This with this, that's negative 3, 22, 39, negative 1, and 33. So this would be your answer, and I think, let me see how many marks this is worth. So 3 marks. So if, I don't even know how you would divide these marks. Chances are they would give you 1 mark for getting the multiplication here, another mark for setting this out, and 1 mark for the final answer. That's the best I could see them allocating the marks for this question. So we should all be able to capitalize on the marks for multiplication and addition. So any question we see where it requires us to add or multiply, we should be able to capitalize on that mark. So the next part of the question, yes?
On the paper, there's no scale or multiplication of the matrices.
We could get that. It all depends on what they give for that particular year. So who knows, we might get scalar multiplication this year. Alright, so find the inverse of A, and they're only giving 2 marks for this. So I don't really appreciate their mark scheme from time to time, but we'll have to work with it. So matrix A was given as 3, 2, 5, 4. I want to find the inverse of this, and this is for 2 marks. So the inverse of a matrix is given as 1 over the determinant of that particular matrix times the adjoint of that particular matrix. Who remembers this formula? So this is how we find the inverse of a 2 by 2 matrix. Well, this is the inverse of a matrix rather. Alright, so that's the inverse of a matrix. So we must now find the determinant and the adjoint. So the adjoint is pretty easy to find. What would be the adjoint of A?
Would it be
4,
5, and 3?
go again, 4,
-5,
and 3.
so to get the adjoint, we switch the elements in the leading diagonal and we change the signs of the elements in the non-leading.
Sir,
Yes?
so why you never put negative for the 4?
Because there's a rule. So to get the adjoint, to obtain the adjoint, so swap elements in the leading diagonal and change the signs of the elements in the non-leading diagonal. So it'll swap the ones in the leading, but we'll change the signs for the ones in the non-leading. Alright, so that's the adjoint, determinant. How do we find the determinant now?
The leading diagonal subtract the non-leading diagonal.
What about the leading diagonal? So we'll just
Yeah,
subtract the numbers here and here from each other.
Now, you multiply the leading diagonal, and then you subtract from the multiplication and the right.
So we need the product of the leading. So it's 3 times 4 minus product of the non-leading, 2 times 5. So this is going to give us 12 minus 10, 2. So the determinant is 2. So we have the determinant and we have the adjoint. Remember, this question is only worth 2 marks. So we can say that A inverse is equal to 1 over the determinant times the adjoint. 4, negative 2, negative 5, and 3. So that's the inverse of matrix A. let's see what's next. So write down the 2 by 2 matrix that represents the product of. Right, so this one is easy. So write down the 2 by 2 matrix that represents the product of A times A inverse. So what did we say when we multiply a matrix times its inverse? What happens?
Sir, is it the thing where I can't remember the name, but basically we get 1 0 0 1?
Yes, so if we multiply a matrix by its inverse, we end up getting the identity matrix. And the identity matrix for a 2 by 2 is 1 0 0 1. And that's all. 1 mark. So matrices, I think this is where you guys should secure some marks for sure. You guys should definitely secure some marks for matrices, because the most difficult thing that they could ask you on the matrices is to do the simultaneous matrix. And for simultaneous matrix, that's basically finding the inverse and multiplying it by whatever was on the other side of the equal sign. That's all you're really doing. And to find the inverse, all you guys should be able to find the inverse of a matrix, a 2 by 2 matrix per se. And addition, not to mention addition and subtraction, scalar multiplication, those should come pretty easy. So let's see what we can check off on the checklist. So for matrices, I'm going to check off inverse. I'm going to check off determinant, simultaneous equation. I'm not going to trouble that as yet. Not transformation matrix as yet. So at least inverse, determinant, adjoint, regular addition, subtraction, those things, right? You guys should be able to tackle those. Alright, let's pull up another paper. Alright, let's see what 2023 has. And I believe we're still having trouble with circle theorems, right?
Yes, sir.
Yes,
But I
sir.
don't remember any of the things.
That's why you should check. Where is it? This, I think this one, marathon day. Which day was it?
Said book on the second day.
On the second day. See them here? Just check back through the document. The video is there that explains the questions and all of that. Let's see what 2023 has in store for us. Alright. Pretty nice and easy question. Can't we all agree? Right, so this is 2023. So this one says L, M, N, and R are points on the. This question seems familiar. It's not one that we did. So we have 4 points on the circumference of the circle with center O. PQ is a tangent to the circle at R. Angle P, where is it? PRL measures 48 degrees. Angle RON measures 156 degrees. So basically, all of the description that we see on the circle was given above. So now it says, find the value of each of the following angles and give reasons for each of your answers. Show all working where appropriate. So the first angle they want us to find is angle R. So whenever we're doing circle theorems question, we need to see if there are any other angles we can fill in first. So before we start finding the angle that they want, we need to check if there are any other angles that we can fill inside of this diagram. So looking at it, and it all depends on what they want from you. If the angle that they want from you requires quite a lot of calculations and so on, then you'd go ahead and fill in. But for now, angle R here, we don't really need to fill in anything as yet, right? Because if we look closely on the diagram, we can see that the angle at the center right here was subtended. So it was formed by this arc. Also, the angle in question that they want us to find was formed by the same arc. So what's the rule that tells us that an angle at the center is what to the angle at the circumference formed by the same arc or even the same chord? What's that property?
Can you repeat the question, please, sir?
I'm asking which one of the rules tells us about an angle formed at the center by an arc and an angle formed at the circumference by that same arc. Or you could even say that chord.
So is it the one about the angle at the center is the best angle of the circumference?
The angle at the center is?
Twice the angle at the circumference.
Yes, that's the one. So the angle at the center is twice the angle at the circumference formed by the same arc. So if the angle at the center is twice this angle, so 156 is twice this angle, so what is this angle?
78.
So R is equal to 156 divided by 2, 78 degrees. And the reason, let's go ahead and copy the reason from here. And remember, the wording doesn't have to be exact, like, it doesn't have to be exactly how the textbook has it. As long as they know that this is the one that you're referring to, should be fine. So that's angle R. So they want us to find angle E, angle A. So angle E and angle A. So let's look at angle E. So angle E is all the way over here. And let's see what we can use to assist us. So far we know alright, so they told us that PQ is tangent, right? And what do we know about the radius and the tangent? A radius that touches the tangent forms what?
90 degrees.
And 90 degrees. So we know that all of over here is 90 degree. So can we find this little inside angle? We can, because what we have here, what kind of triangle is this? Isosceles triangle. And if it's an isosceles triangle and we know the central angle, we can easily find the two angles here. So this is 156. So we can say, so the calculations for this one will be, so a triangle NOR. So triangle NOR is isosceles. So angle ORN is equal to 180 minus 156 divided by 2. So what's that?
12.
So if this little piece is 12, what is E?
78.
78 degrees. So angle, let's see. And then remember that they want the property, or at least a property to go with this. So we could say that angle NRQ, which is the same thing as E here, is equal to 90 minus 12, 78 degrees. So therefore, E, and the rule or the theorem that we're going to use for this one is the one that the angle between the radius and tangent forms a 90 degree. So angle between radius and tangent forms a 90 degree. So that's the one that we're going to use for that. So once you're able to isolate the different parts of the question, you should be fine. It shouldn't really take much out of you to get these answers. So now they want us to find angle A. Alright, so angle A is over here. But if you look at the bigger picture, we should know, or we should be able to see that we can form something like this. And what's this?
A cyclic quadrilateral.
Alright, so we form a cyclic quadrilateral. And what do we know about a cyclic quadrilateral?
Opposing angles equal 180.
So opposing angles add up to 180.
Add up to.
So in order for us to find angle A, we'd need to find this entire angle over here. And would it be possible to find this angle here? We already know that this little piece is 12. So can we find this piece inside here? Let me shade it.
Yes, sir.
How are we going to find it?
Can we subtract 48 from 90?
So we can subtract 48 from 90. That gives us
42.
So this little piece inside here is 42. This piece here is 12. So the entire angle right here is what?
54.
54. So that would make A being equal to 180 subtract 54, and that's what?
26.
And then the rule that would govern this one is cyclic. So opposing angle in a cyclic quadrilateral adds up to 180. Pretty straightforward. Any questions on this?
I can show you how you got the 54 again, please.
Alright, so the 54 would cover this entire angle over here. So we already knew that this little piece is 12 based on the isosceles triangle that we have here. We knew that this little piece is 12. So to get the 42 degrees, we observe that what we have is another right angle from here to here. That's a right angle. The radius and the tangent, so it forms a 90 degree over this side. So if we know that this piece is 48, that means this inner piece shaded in blue must be 42. So if this piece is 42 and over here is 12, we simply add both of them and we get the 54. And we'll subtract from 180 because the entire angle over here is 54. Subtract from 180 to get what angle A is.
Okay, thank you.
Alright, so let's look at another one. Let's see. Somebody give me a random year.
2010.
2020.
Alright, let's see 2010. Circle theorem.
Couldn't have picked a better year. What is this?
Alright, so this is from 2010. So in the diagram below, not drawn to scale, PQ is a tangent to the circle. PTSR. So PTSR, we have a cyclic quadrilateral inside here. So as we go along with us, I make a note of what we have. Angle RPQ. So RPQ. So this angle right here, so 46 degree. Angle RQP, 32 degrees. And TRQ, where is it? TRQ, so this is a straight line. Calculate, given a reason for each step. For each step they want a reason, okay. Angle PTR. So this is the angle that they want first. Angle PTR. Alright, so we don't have any center working with for this question. Let's see what other information we have. So we have a straight line going through. So we can easily find this angle, this angle. But we can't find anything up here as yet. So we have a tangent and we have an angle here. So the angle in the opposing segment, so this should be 46 as well. based on the, where is it, this theorem, this one. So based on the alternate segment theorem, and because this is upside down, so sometimes you'll have to even flip your paper around to see what's there. So look at it. We have a tangent, and we also have a chord here. So here is it, tangent, chord. So the angle formed, it wouldn't even be that one. Hold on, let me flip this around. It would have to be in the alternate, on the opposite side of the triangle, so it couldn't be this one. Let me just fill in some things. So this angle right here, so it's angles in a triangle add up to 180. So this is 46, 32. So that's 78. So 180 minus 78. That's 102. So if that is 102, this angle right here is 78. It's angle on a straight line. Yeah man, this definitely has to be 46. It's the way the diagram is oriented, it's flipped. And let's see what else they want. They want TPR. So they want this angle as well. And they want TSR. This angle as well. Shaniko, you couldn't pick a better question.
Well, sir, I do think it is 46 because if I add 78 and 46, that would leave 124, and if we subtract that, we get 56. And if you look on P, you would add 56 plus 48, you would get back 78, and that would be 180 on a straight line. So I do think it is.
Let's work with it. It's the orientation of the diagram that's throwing me off. So if we say here is 46 as well, so this would be alternate segment theorem. Alright, so let's work with it. So if this is 46, this is 32 up here, so we can find this angle by looking at the big triangle. So look, this forms a big triangle here, and we know that this is 32, this is 46. So over here we can eventually find this angle, and it would be what? 180 subtract 46 plus 46 plus 32, and that gives us what?
$56. Oh, I was right.
So if this is 56, this one here is what? This is opposite angle in a cyclic quadrilateral.
124.
So 180 subtract 56.
124.
So remember the rules would be cyclic quadrilateral for that one. So this one is cyclic quadrilateral. So sometimes we have to really look at these diagrams and flip our paper, turn them around and all of that. So the one up here, so this would just be angling a triangle add up to 180. But for 3 marks and 2 marks, they would want you to give them a step each. So each step you take, you give them a little working out, or you'd explain something. So if we subtract that from that, we'd have to tell them that the angle in a triangle add up to 180. So that's why we subtracted this to find this angle. Angle in a straight line add up to 180. So that is why we subtracted that from that, and so on. So each step that you take, you'd have to give them the reason for it. Clear? And we went through the question that I gave on the mock exam, right? We did that one in class. We never did that one there. So fifth form. Bringing back trauma. Alright, so let's see what can happen for this one. Let's quickly go through this and then think of which other topic you want us to look at next. I think we can look at a few construction. We haven't really touched on that much. Alright, so the diagram below, A, B, C, D, and E are points on the circumference of a circle. AD is the diameter of the circle. So AD is the diameter. The line ST is tangent at point tangent to circle. Wait, this should have been D. Oh well. Angle OEC equal 21. Angle BED, no, EBD equal 48. And DBT equal 72. So they want us to find CED. So we're going to find CED. So down here, this is what they want us to find. Alright, so let's see. So what was the challenging aspect to this question? Tori, what did you find challenging about this question? Let's see who is still with me. Shaniqua?
Everything.
Alright, so remember, when we get a question such as this one, we have to try and identify things that we might need. So one of the more important things for us to find is what this angle at the center is. So look at it. They gave us the angle formed at the circumference, and if we want to find the angle at the center, that will be what?
Twice the angle at the circumference.
Exactly.
Which is 96.
So we can find that first. Fill in the 96 right there. And the reason for filling in that 96 is because we're going to have an isosceles triangle inside here. And if this is an isosceles triangle, this is 96. Shouldn't we be able to find these two angles?
Yes, sir.
Alright, so let's see. So this is 96. What is this angle here?
42.
So if that's 42, all of this is 42. And if all that is 42, this piece is 21. So what is this piece?
21.
21. Very, very easy. And of course, you would show the working out as you go along. So that's very, very much easy. It's just that when doing these questions, you need to be able to identify the different aspects of the diagram. Let's see what else they want. EAD. No, that one is a free marks. So they want us to tell them what so EAD. So this down to that right there. But if we look at it, we can see that this formed an angle up here as well. And which property is that portraying?
Alternate opposites matter.
Alternate what? I don't know the law there. Alternate opposing segment.
So is it the one that the angles on the same chord that touches the circumference equals the same?
Yes, so it's that one. So angles formed by the same chord that touches the circumference, or angles in the same segment formed by the same chord, are equal. So there are different wording for the theorems. So if that is 48 here, this would be 48 as well. And then the last angle that they want us to find is BED. BED. So they want us to find this angle down here. So we have majority of the angle already. We know this piece. We know this piece, but we don't know what this little piece inside here is. So let's see how we can find it. Alright, so let's see. So looking at this diagram, one theorem that would be very helpful to us is the angle formed by a tangent and a chord is equal to, let's see, yeah, that one would help us. So angle formed by a tangent and a chord, so a chord and a tangent, so the angle formed by this tangent and chord is equal to the angle formed in the opposing wait, I couldn't that alone may give one of you. How much mark can I give you this part? be that simple. Let's see. Don't think it should be that simple. How much marks for that? Oh, it's just that. Why do I think it was more difficult than that? So it's just angle formed by the so alternate segment theorem. Angle formed by a chord and a tangent is equal to the angle formed in the opposing end of the triangle. So all of this would add up to 72 because this is 72. So that's the reasoning behind that. So that question, it wasn't bad, you know. It's just that it had quite a lot of lines compared to what you would use to see in a regular question like this. Alright, so we've looked at 3 circle theorem questions. And so how are we with trigonometry? Bearings per se.
I think I'm doing a bit better on that.
Because if I can recall, nobody got the question correct on the exam. And it was a pretty basic question. Where would that fall? That would fall under question. Alright, so let's look at 2 bearings question. So this is from 2025 paper. How was the paper from the marathon? The one that you guys had the other day over the Easter break.
It wasn't bad.
And usually what would happen is that
Sir, it was January 2026.
yeah, so usually some things might replicate from that paper on the June paper. So maybe the question structure or the types of questions that they ask, but usually the case is that some things might pop up back on the June paper. Alright, so let's see what this one is saying. So this is from 2025. So a ship sails from point A to point B, which is 15 kilometers from A on a bearing of 042 degrees. The ship then sails to point C, which is 19 kilometers from B on a bearing of 130 degrees. The following diagram shows a sketch of the ship's journey. On the diagram, insert the bearings 042 and 130. Calculate the distance between town A and town C. Alright, so the first thing that they told us is that so the ship sails from point A to point B, which is 15 kilometers on a bearing of 042. So we know, or we should know, that bearings start at the right of the north line. So we have a north line here, we have a north line here. So bearings start from the right in a clockwise direction, clockwise, clockwise. So looking at these three angles, which one could possibly be 42 degrees? This one, or this one? Which one could be 42 degrees?
So the first one is draw from each.
So the first one here. And it even gave you in the question, it says from A. So we know that the bearing is going to be here. So that's 0.42. And they told us that it has a distance of 15 kilometers. And so this will be point B then. Let's put a B on the inside. So that's point B right here. And so the ship then sails to point C, which is 19 kilometers on a bearing of 130. So that's basically all the information that they gave us. So this will be point C. And they want us to calculate the distance between A and C. So this distance, that's the unknown. So in order for us to calculate that distance, we need a few things. For one, we need to know this angle inside here. Why do we need that angle? What's the reasoning behind that?
Can you repeat the question, please?
Why do we need to know this angle inside here? What good will it do for us in solving for the missing side?
Sir, it will tell us whether to use the cosine or sine rule.
Alright, so it will give us a little hint as to which one of the rules we are supposed to use. But from looking at this question, the first rule that should come to your mind is the cosine rule. Because in order for us to use the sine rule, we would need
We need to have two angles.
two angles. So we need another angle inside there. So the only one with one angle would be the cosine rule. So let's see how we can find this angle inside here. So we know that this is 130. So in order to find the angle inside here, we need to know what this little piece out here is. And how can we find that piece?
So would you subtract losses from 180?
Why would you do that? Which rule?
Angles of a straight line equal 180.
Angle on a straight line? That's not the rule that's here. Remember, the north lines are parallel. And if we have parallel, we'll call them two inside angles. So
Co-interior.
co-interior. So the angle here and right here so would be co-interior. Co-interior angles add up to 180. So this is 42. This angle would be 180 minus 42, which is 138 degrees. So we know that this piece is 138, this is 130. How we get the inside piece here now?
Subtract both of them from 360.
So 360 subtract 130. What does that give us?
90. 2.
So 92 degrees. Alright, so we know the angle and we know two sides. So we can apply our cosine rule to find the missing side. So how the cosine rule go again?
Sine something over sine something.
Cosine rule?
Oh, no. Wait.
And by the way, what are we trying to find? What side of this triangle would we label it? So down here, so what I label that side of the triangle? If we did have a triangle here, so what would be the label for this missing side? This.
Unknown.
Yeah, it's
X.
unknown, but which letter?
X.
C, no, C.
No,
because it
we
was
already
with
have-
hypotenuse.
We already have labels for the triangle A, B, C. So what would this one be down here?
C, sir.
You sure?
Small c. B.
Small b, remember.
Yeah.
Capital B over there, so small b I go down here, so.
And then small a is 19.
Small a would over here, so small c over there, so. So remember that it's why is this lagging? So now that we have that established, we can go ahead and apply the cosine rule. So remember, I told you guys that whenever we're using the cosine rule, whatever we're trying to find will always start or end the formula that we use, the variation of the formula. So if we're trying to find b, we're going to say b squared is equal to a squared plus c squared minus 2ac cos b. So whatever we're trying to find will always start or end the formula. So if we're trying to find a, we start at a squared is equal to b squared plus c squared and so on. So that's how we maneuver the formula. So let's substitute. So we don't know b squared, we don't know b, so that's what we want to find. So a squared, so that's 19, 15 squared minus 2, 19, 15 cos 92. So you can put all of this in your calculator and get your answer.
Sir, would we get full marks if we do that?
I think this question is like 2 marks, you know. Let's see. 2 marks. So yeah. Remember, CSEC is very stingy with their marks. So they can't really expect you to do that much for little or no. Well, they do expect you to do a lot, which is crazy sometimes. So this would be 19 squared, 15 squared, minus 2 times 19 times 15 cos 92. So 605.89. And before you round this off or anything, so remember, in order to get b, we're going to have to take the square root of whatever answer we get, right? So you can write all of what was there. So 605.89. Can I copy this now? So 605.8927. So this would be your b squared. So to get b, we simply take the square root So square root of answer 24.6. So this is where you would round off now. So 24.6. And the reason why I rounded off like this is because on the cover sheet, or where they give you the instructions, they specifically state that if you are doing a question and it didn't tell you what to round off to, always round off to 3 significant figures. So they mentioned that on the front page of the document. It's not on this one. This one will be the old version, so it's not on. I'm pretty sure I've seen it on some of them, that it says if you aren't told what to round off to, then you do 3 significant figures. So now they want us to determine the bearing of tone A from tone C. So bearing of tone A from tone C. So if we're starting at tone C, what do we need to do?
So repeat.
So they want us to tell them the bearing of tone A from tone C. So we're starting at tone C. So what did we say about the bearing? How we draw it?
Draw it towards A.
Towards A like this.
The other way.
So we start at the right of the north line. We move in a clockwise direction until we get to the line that connects both points. So we start at the right of the north line, move in a clockwise direction until we get to the line that connects both points. Alright, so this one looks like it's going to require a little bit more from us. So they gave us, so we need to find this entire angle out here. So far, we should be able to find this piece. And this piece inside here is what?
50. Yes, I'm here.
So that's 50. So we still need to know what this piece inside here is. So this is what we need to find. So how can we find that this is the piece inside here? Which rule can we use now? No idea?
Can you repeat, please?
Which rule can we use now to find this green shaded piece? Alright, so we can use the sign rule. So this, so A. Right, so what are we using? We're using C. So we're going to use C and B. So B over sine B is equal to C over sine C. So we know what B is, we just calculated it. So 24.6 over sine 92, and we know the angle right there, so is equal to 15 over sine C. So cross multiply. So 24.6 sine C is equal to 15 sine 92. Sine C is equal to 15. So this just comes down to transposition. And then C is equal to sine inverse of all of that. So this piece inside here, so when you put that on a calculator, so shift sine 15 sine 92, 24.6, so that's 37.55. You can say 37.5. So if this green piece inside here is 37.5, this is 50. How do we get this entire blue piece out here?
Add them and then subtract from 360.
So bearing of A from C is equal to 360 subtract 50 plus 37.5, and what does that give us?
Check 272.5.
So that would be your answer to that particular question. So when doing Behrens questions, the most that you'll get is just sine and cosine rule. Shaniqua, your mic.
Oh.
Alright, so that's how we approach these types of questions. Nothing to overcomplicate or think about too much. And we just have to approach these questions practically. Identify what we have, identify what we need, and how we can get there. Right, so let's see what else we can look at. So somebody has given me another year.
2024.
2024. So let's see. I want to look at some of these volume questions as well. So this is 2024 question question 9. Alright, so diagram below shows a quadrilateral PQRS formed by joining two triangles PQS and R and QRS. Calculate the length of QR. So remember, whenever we get to these types of questions, they usually ask us to apply some form of trig. So it's usually sine rule or cosine rule for the most part. If you see any other trig elsewhere on the paper, like in question 3 or 4 thereabout, those ones would usually be testing your trig ratios, so SOHCAHTOA or Pythagoras theorem. But these ones that you encounter at question 9 are usually trig 2, which requires knowledge of sine and cosine rule. So calculate QR. So this is our unknown. And looking at it, this should be pretty simple to calculate, because we have a triangle, and from our triangle, what do we know?
Adds up to 180.
Yeah, we know that inside angles add up to 180, but they don't want us to find an angle. They said calculate the length of QR. So looking at this closely, we see that we know two sides on the triangle and an angle that points to the missing side. So which rule is that? So we have a triangle, two sides known,
Cosine.
so we have to apply the cosine rule again. And remember, the cosine rule is given on your formula sheet. So you can easily apply it from there. But the difficulty comes when trying to identify which variation of the cosine rule we use. So seeing that our triangle isn't labeled with ABC, how do we write this out now? Which variation, or how do we write what we're trying to find now?
Sir,
Yes?
sir, would cosine rule be on the formula sheet?
Yes, it is.
Oh,
So look at this now. This triangle, it isn't labeled ABC, it's SRQ. So over here, this would be small s, this would be small r, this would be small q. So how do we write up this cosine rule now?
So I wanted to say like S equal Q square plus R square minus QR cos S.
Yeah, so we write it, so we want to find s. So we have to start with it. So s squared is equal to r squared q squared so just like this. Whatever we want to find, that's what we start with, or that's what we end with. Because when using the cosine rule, it's either you're going to ask you to find the length of a side or a missing angle. So whichever one, we write it like this. So let's substitute what we know. So s squared is equal to, so 18 squared plus 16 squared minus 2 times 18 16 cos 25. So s is equal to the square root of whatever our calculator tells us that is. So 18 squared, 16 squared, 18 cos 25. So that's 57 point, all of that, 96671,467. So don't round off just yet, you know, just work with what that gives you. So 57.96671,467. So when you take the square root, so square root, so 7.6. Is that clear?
Sir, would it be 7.61? Because three significant figures.
Alright, so you have a very valid point. So 7.61 meters would be your answer to this question. Now let's see what else they want from us. Right, so this one is 3 marks. Some years they are more lenient with the marks than others. So determine the bearing of S. Hold on, the bearing of S is 205. The bearing of P from S. Oh, P from S is 205. Determine the bearing of R from S. Okay. That looks like 3 marks. So let's see. So they said that the bearing of P from S. So when dealing with bearings, what do we need to ensure we have on our diagram?
North line.
We need our north lines. So let's put our north line here, and they want R from S. Okay, so that's north line right here. So they said the bearing of P from S. So if we want the bearing of P from S, we have to start at the right of the north line. We move in a clockwise direction until we get to the line that connects both points. So always remember that you move in a clockwise direction until you get to the line that connects both points. So they told us that all of this up here so at 205 degrees. That's basically what they are telling us. All of this is 205 degrees. And they want us to tell them the bearing of R from S. So the bearing of R from S, so we'd start at S again. We'd move in a clockwise direction until we get to the line connecting both points. This is S, this is R. So the bearing of R from S would just be this little piece. So how do we find this little piece up here? So if all of this are 205, what is this little piece up here?
Sir, you would add 72 plus 25 and then subtract it from 205. Exactly.
So this is going to be 205 subtract 72, 25. That gives us
108.
So therefore the bearing of R from S is 108 degrees. Simple.
So I can explain the 205 again.
Alright, so they told us that the bearing of P from S is 205. So all of this around here so is 205. But we know two pieces of this already. We know the 72 here and the 25 here. So to get the bearing of R from S, so remember, we need to find the bearing of R from S. So if we're starting at S, we have to move in a clockwise direction until we get to the line that connects both points. So it's just this little piece at the top. So we know that the entire thing is 205. This is 72, this is 25. So if we add up both of these and subtract, we should be able to get this little piece at the top. And doing that, we ended up with 108. So the bearing of R from S, so just this little piece up here, is 108 degrees. Get it? So let's see what else they're asking of us. The bearing of S from P. Let's see, S from P. So it would be this piece here. So, and that as well is very easy. So let's put that here. So bearing of S from P. So S from P would be this little angle right here, correct? Is that what we want to find?
Yes, sir.
So what do we know that can assist us?
If you subtract 360 from 205, you get 155.
360 from 205? Oh.
Yes.
So we can find this angle up here, so.
And then you subtract it from 180.
Right, so this little angle here is 360, subtract 205. That gives us
155.
so down here now would be 180 subtract 155. What is it?
25.
So therefore S from P is 25 degrees. So pretty much that's it for bearings. All they would normally ask you to do for these types of questions is either they're going to ask you to find a missing side of the triangle, or they're going to ask you to find the angles using sine and cosine rule. So that's what you would expect to use for these types of questions, sine and cosine rule. Alright, so let's look at a few measurement questions. Saw some good one on this. And how are we with the pattern questions? I gave you guys a formula, so you should be utilizing it when necessary. Alright, so question 6, this is where you'd usually find your measurement questions. So these questions typically test volume, area, surface area, and those types of things. So this is still from 2024. So the diagram below shows a gold bar in the shape of a trapezoidal prism, and we know that prisms, it's basically a particular shape where if we cut it, we should be able to get that same cross section throughout. So if we should cut this prism down the line here, we're going to have a basically the same shape throughout if we should cut through it. So that's what we define a prism as. So its volume is 2,886 cubic centimeters. The length and height of the prism are indicated in the diagram. Calculate the area of the shaded cross section of the trapezoidal prism. Alright, so this one is pretty simple. So firstly, we can establish the area of a prism. So the area of a prism is just cross-sectional area times the length. Could be length or height, it's just the same. So cross-sectional area times the length of the prism. And this goes for all prisms. Area of the cross section times the length, that's going to, I shouldn't say, it should be volume, sorry. It should be volume. So the volume is cross sectional area times the length. So they gave us the volume 2,886 and they want us to tell them the cross sectional area. That's what we don't know. The length we do know. So to get the cross-sectional area, we simply divide so dividing this will give us 92.5. And what's the unit?
Centimeter
Cross.
squared.
Okay, so it's area, so it's centimeter squared. And that's for, I believe, 1 mark. Just divide that by that to get your answer, 1 mark. So they said that the cuboid shape, but it's gone to a different something. So there's one little something I ask you for that. Because they know it easy, you know, them now giving much on it. Alright, so the cuboid shaped gold bar below has the same volume. Oh, it linked. So it has the same volume as the trapezoidal prism gold bar. Calculate the height of the cuboid shaped gold bar. So they say that it has the same volume. So the volume that they gave us for this one was 2,886 cubic centimeter. So that means the volume for this one cubic centimeter. So how do we find the volume of a cuboid?
Length times width times height.
So the volume of a cuboid is equal to length times width times height. So we know the length and the width. So 30.6 times 8.2, and the height is unknown. So they also gave us the volume, so we can easily solve this. So 30.6 times 8.2, so that's 250.92. So to get h, we divide. So dividing 2886 by answer 11.5. Simple. Any questions on that?
No, sir.
Alright, so let's see what else. So the trapezoidal gold bar is melted down and all the gold is used to make 6 identical spheres. Calculate for each sphere of gold its radius, surface area. Interesting. Why am I done? Alright, so them say the trapezoidal gold bar melted down and all gold is used to make 6 identical spheres. So these are the types of questions that will require you to think and reason what is being asked of you. Alright, so if they're going to make 6 identical spheres, that means the volume of the trapezoidal cuboid, trapezoidal prism should be divided into 6. Agreed? So that's the volume.
Yes, sir.
So the volume of each sphere is equal to, so 2886 divided by 6,
481.
so 481 centimeter cube. So this is going to be the volume of each sphere. But they don't want us to tell them the volume, they want the radius. So to get the radius, we have to apply the volume formula that they provided with us with here. So the volume is equal to, so volume 4 over 3 by r cubed, and we know the volume is 481, so that's 4 over 3 times, and they told us to use pi as, did they say?
22 over 7.
They mentioned it? Oh, up top. So pi is 22 over 7, and the radius we don't know. So let's simplify. So 481, 88 over 21. So let's multiply these across. So to get rid of this 88 over 21, what we can do is multiply both sides by 21. So that cancels. So this times 21 is what? So this is equal to 88 r cubed divided by 88. What you get? Give me some more decimal places.
Okay, so 7840.
7, 8. So you get 7, 9 a while ago.
Oh, they don't mind.
So r is equal to the cube root of 1147840. So r is equal to
4.859.
so 4.86. So therefore the radius of each sphere is going to be 4.86 centimeter. Alright, not bad. So I have to just look at what they gave us, what they want from us, and how we can link the things together. So the last part says, wait, not the last part. Yes?
You can go over that again, please.
So they told us that the trapezoidal gold bar is going to be melted down to make 6 identical spheres. So that means each of those spheres must have the same volume. So now we took the volume of the trapezoidal gold bar and divided it by 6. So each sphere is going to have a volume of 481 centimeters cube. Following?
Yes, sir.
So they gave us the volume formula for a sphere. So what we did was replace, so the 481, that's going to be for each individual sphere. So we know that the volume of each sphere is going to be 481. So 481 is equal to, so in the formula we replace what we know. We know pi as 22/7, but we don't know r as yet. So r is what we're trying to find. So after some cross multiplying, so we had multiplied 4 times 22, 3 times 7 to get this 88/21. Then we multiply both sides by 21 because we're trying to get r by itself. Multiply both sides by 21, ended up with this 88r cubed. So to get r by itself, we still have to divide by 88. So r cubed is equal to this. Then we take the cube root. After taking the cube root, this would be your result. So the radius of each sphere is 4.86 centimeter. Is that clear?
Yes, sir. Yes, sir.
So now they are asking us for the surface area, and I'm assuming that's for each sphere. So the surface area for each sphere. So they gave us a formula, and the formula says, so the area for each sphere is 4 pi r squared. So we know what r is. That's the purpose of finding r around here. So we can substitute it. So 4 times 22/7, 4.86 squared. So after plugging this in your calculator, this will give you the surface area for each of them. So it's 296.9 centimeters squared. And this will be the surface area for each one of the spheres. So we already have r, so let's plug it in here and we use it. Alright, so the last part now they're asking us for density. So you see that these types of questions can come with all sorts of things. Yes.
For the one where you find the radius, what you type in the calculator when you reach there, so yeah, where your mouse is.
So it's cube root. So the cube root of 114.7840. Good?
Thanks, sir.
You're welcome. Alright, so this one says mass to the nearest kilogram. Given that the density of the gold bar is 19.3 grams per cubic centimeter. This is first I'm seeing one that's asking for mass or anything like this. So let's see. Alright, so they want us to find the mass. But they gave us the density. And the density is 19.3 grams per cubic centimeter. So that's what the density is. That's equal to mass over, so we know the volume of each of them, 481 so this is the volume, this is the density given. So to find the mass, we simply cross multiply. So we multiply by 481. So what do we get? So Shanique wanna work with me now.
Sir, the woman just called me from the English class a while ago. So no, what you say? I never hear.
We want to find the mass, so we're multiplying the density times the volume. So 481 times 19.3, so 9,283.3 grams. 9,283. So this is quite heavy. This is quite heavy. Piece of gold bar. Alright, so that's it for this particular question on this year. Kai, give me another year. 2021. So let's see what question 6 has in store for us. Whoa. Kai, why you pick this one?
It's a good thing.
Why did Kai pick this one? Alright, so Farmer Brown makes troughs to feed his farm animals. So using wood that is 5 centimeters thick, as shown in the diagram below. So the troughs are rectangular based, open at the top, and have external dimensions of 300 centimeter by 190 centimeter by 160 centimeter. Show by calculation that the internal capacity volume of the trough is 8,991,000 cubic centimeter. Alright, so they want volume, but they said that it's the internal capacity. What that means is we will have to factor out the thickness of the wood that has been used. So the 5 centimeter thickness here would have to be factored out. So we need to factor out 5 centimeter thickness from all around it. So let's see how we can do that now. So if this is one, but I'm not sure if the base, let me see, using wood 5 centimeters thick. So here's the thing now, I'm not sure if the base would be using that same concept, so I'm going to assume that it's not and just use the 5 centimeter for the sides. So for the side that is 300 here, 5 centimeter would have to be taken from here so and here so, because of the thickness of the board. For the 190, 5 centimeters would have to be taken from here and here as well. And let's see, so 300 we take out the 5, we take out the 5. So the 160 around the back there, 5 and 5 would have to come out of it as well. Well, that's the height. So the height wouldn't be affected. So let's see. So if we're going to take away 5 from here so, 5 from here so we minus 5 here, so minus 5 here so, minus 5, minus 5. So this 300 now becomes
290.
So 290 times, so this 190 becomes 180, and 160 now, let's work with 160 because the bottom or the base of this trough, we can't guarantee if there's a 5 centimeter thickness down there as well. So let's just work with this to see if we'll get the answer. So multiply these three numbers for me and let me know what you get.
So I got the answer.
So the same thing right here.
No, sir. 8 more.
More?
Well,
Also,
8 million.
I multiplied it by 155 instead of 160, and I got an answer.
So that means we'd have to assume that the base has a 5 centimeter taken out from it as well, which theoretically doesn't really make sense, but because if you were to build something like this, I guess it's like a box, so we have to factor out the 5 centimeter from here so as well. Well, it's a good thing that they gave you the answer, so you know what you're working towards. And if you didn't get the answer correctly the first time, you could adjust these accordingly. Alright, so this is an interesting question. Alright, so calculate the volume of wood needed to make the trough. Alright, calculate the volume of wood needed to make the trough. You see if it makes sense? Let's see. The assumption of going yes or no, you know. So if we say that we're going to use 290 here, so that means, but in the volume we have to factor back in the 5 them. But the question is, how are these things joined? Like, how are they joined at the edges? That's the question to be asked here. So do we cut piece from the 300 and then this 190 is going to align perfectly and we put on, we screw them or whatever here? So I think this question is a bit vague. Like if we were just to look at the question and pick out what they want from us, it's a bit vague, if you ask me. Because how do we know which piece we should cut off from to connect the vertices or the edges? You see what I'm saying? Like if we cut off piece here, so to attach this entire 190 section, do we still, alright, probably just work it with see how much marks for this. 3 marks. So volume, right, let's look at this 300 centimeter surface. So the volume of this piece would be, so 300 times no, this question don't make no sense.
So you just move on and up so when you get it.
Because how you gonna know which piece of the board you have cut off from to get the connections? So I'm gonna require some whole heap of trial and error and reasoning in this. So 290, if we say 290 times 5 times 5, wouldn't be 5 times 5. Let's keep this question, this thing here not really add up. I guess it's the way how they drew the diagram. It's not easy to pick out what they really want from you. So I gotta take some sketching and all of that. I don't have time for that right now. But we can look at the solutions after to see how they would have wanted us to approach it. Let's leave that there for now. Alright, so that's it for that question. So we didn't look at any coordinate geometry. I think we should all be good with coordinate geometry. So coordinate geometry and functions, quadratic graphs, we should all be good with those topics, right?
Yes, sir.
Let's see. So transformation. Triangle X is mapped onto triangle Y via reflection. Alright, so these are the basic transformations. So whenever you see transformation in question 3, it will be like the simple ones. Where it just ask you to identify what transformation took place. They would ask you to give them the translation vector and so on and so forth. So these ones are pretty simple. But if you see transformation in like question, I think 6 or 8, somewhere around there, those ones are usually the matrix transformation type questions. And of course, you know your question 1 and 2. So numbers. So all of this is numbers, standard form, percentages. So let's look at this one. Let's just do question 1 from 2021 paper. And I don't think we should have any problem with this. They said using a calculator or otherwise calculate the exact value. So to save time, just go on your calculator. And what I've seen some of you guys do is like this. So 1 and 4 over 7, sometimes I see you doing something like this. You have the 1, and then beside it you put 4. Well, this is not allowing me to show you. So you'd have a 1 in front of the 4 over 7. What this is telling you is that it's saying 1 times 4 over 7 if you write it like this on a calculator. There's a specific button. So you see where we have the fraction. If you press shift and press that button, this is what will give you the mixed fraction option. So on your calculator, where you see the fraction button, if you press shift and press it, this is where you'll place your mixed fraction.
Okay.
Because sometimes I see things like this. So let's say we have 4 over 9 and you got 7 and 4 over 9 as your fraction. Sometimes I see things like this. This is not 7 and 4 over 9, you know, if you put it on a calculator like this. This is saying 7 times 4 over 9. So you have to ensure that you press the button to get the mixed fraction option. So 1 and 4 over 7. Or if you don't have the mixed fraction option, just convert it to an improper fraction and put that in your calculator. Divided by 2 over 3 minus 1 . So this is 9 over 14. You move on with your day.
Sir, So if we just put that way, you get the full mark, right?
Yes. Because they said using a calculator. If it didn't say using a calculator, then you'd have to show the working out.
Sir, and suppose you don't show the work,
You get your marks.
but then probably take off one because I'm not show the work.
No, they won't take off any mark. Once they say using a calculator, so by getting the answer, it would show that you know how to use your calculator to approach the question. Using calculator is a skill, because not everyone can use it properly.
So why them not just now skilling a paper?
That would you know. Want too much out of life. Alright,
It's just right.
so let's see. So when Megan started working, she was paid $85 each week. After a 6-month probationary period, her pay was increased by 20%. How much was she paid each week after the increase? So she started working and she was getting $85 each week. So after 6 months, they increased her pay by 20%. So how much is her new pay? So we can simply do that. So 2 ways we can do it. This $85 would represent 100% of her pay, right? That's what $85 would represent, 100% of her pay, correct?
Yes, sir.
So if it is increased by 20%, what we can do is to find 120% of her pay. So this is 120 over 100 times 85, and that gives us $102. So this is the first way. Second way is by finding 20% of that money. So 20% of 85 is what? So $17, and we'll just add it. So $85 plus 17, $102. So you have option 1 or option 2. So whichever way you choose. Same result. Same marks, same everything.
Sir, I have a trick to make percentage easier.
Wait, you take off the 0 and carry over the decimal point and do that and that.
So I just divide by 10.
Then the same thing,
So
take off the 0. But it doesn't work for everything. So let's say you wanted to find 35% of 92. There's no 10 and no something there, so. But it will work if you have things like 20% of 150. So you take off that 2 times 15, 30. So it will work for that. But it doesn't work. Well, it technically it does. Because
Just in decimal.
yeah, it will be decimal. So 35% of 92. So it's going to be 3.5 times 9.2.
32.2.
Yeah, so it would work like that.
So I remember say they will go for the Z sum. Interior angle.
Alright. Shall we just finish up this question first? So in 1965, the population of a country was 2,714,000. In 2015, the population was 3,663,900. Write the population in 2015 correct to three significant figures. So what's that?
Sir, is it 3.66 times 10 to the fifth?
It didn't say. It never say standard form.
I don't know, man.
It says three significant figures, not standard form. So how we do this again? Kai, you did tell me say you master this last time.
Me?
Mm-hmm. So what do we do in this case? We identify what's in the third significant position, and that would be what?
Six.
The 6. Which one of them?
The circumference.
So this is in the third significant position.
Oh.
Then we look at the number that comes after it. So it's less than 5. So we're going to change everything behind here to 0.
So would that be 3660000?
Mm-hmm. That would be your answer.
Why?
That's just how significant figures are.
Alright, so sir, if it was more than 3, would that be?
If it was 4 significant figures, what would we write?
3664000.
Yes, because we look at the what's in the fourth significant position, then we realize that we have a 9 after it. So that means this would have to be rounded up to 4, and then everything else is just 0. So that's how we approach significant figures. Alright, so a pretty easy mark right there. So now they want it in standard form. Well, the population in 1965 in standard form. So how standard form go again?
2,700,000. Yeah.
Well, that's the number. So in 1965 the population was 2,714,000. So in standard form,
form would it be?
go ahead.
So I was asking if it would be 2.714 times 10 to the 6.
Yes, so that would be it. Give me a second. Alright, so that would be the answer. So for standard form, if we have a whole number, there will be an imaginary decimal place at the end. And for a standard form, when writing it like that, the number that goes here, so it's usually a point, let's say times 10 to the n, and a here must be between 1 and 9. So the number that goes in front of the decimal point when you're writing your answer must be between 1 and 9. So to get the number of the value of n here, we count off the position. So so 1 space, 2 space, 3, 4, 5, 6. So we move 6 spaces to get the decimal point here. So that's why we have 10 to the 6. And it's a positive 6 because we're going from a bigger number to a smaller number. So if we had 0.0003521, if we wanted to change this to standard form, we do the same thing. We'd move the decimal point until we get it to having one number in front of it. So it would be 3.521 times 10, and we moved 1, 2, 3, 4. But because we're moving from a smaller number to a bigger number, because this 0.00 something is smaller than this number, right? 3 point this. So we're moving from a smaller to a bigger, so it has to be negative. This one at top, we're moving from a bigger to a smaller, so it has to be positive, the number up here. So just keep that in mind. I think, did we go through that in our sessions that we had? I'm not sure if we did significant. I'm not sure if we did significant figures.
Sir,
Standard form, sorry, standard form.
sir, where on the paper would these questions fall?
Question 1. So I have to try and capitalize on some marks here. So question 1 usually come with fraction, as you know, money business, percentages, and these types of things. Significant figures, decimal, standard form, and so on and so forth. Ratio. Alright, so determine the percentage increase in the population. Alright, so we should all be able to calculate the percentage increase. So we can do so. By finding the difference in population first. So percentage increase, so between that and that, so it was 2714 2 3663 900. So this is what we have. So how do we find what percentage we increase by? What can we do here?
Sir, what are we doing?
we want to find what is the percentage increase. So this population in 1965 would be 100% of the population. Over here, we don't know what this percentage is. So what are the ways we can do this?
Sir, would we subtract the bigger number from the smaller number and then do something?
The bigger from the smaller, that now give you negative.
The smaller from the bigger.
Alright, so to find the difference in population, we say 366 3900 subtract 2714, and that's why this thing on and off.
949,900.
Hold on, the tablet is glitching out, man. Give me a second. This thing here choose to act up now. Alright, go ahead.
949,900.
So this would be the number of people that we got the increase from. So what do we put this over to find the percentage increase?
100.
Over 100? No.
110,000.
Put it over what? Remember, this is the original population. The original population grew by 949,000 people. So we have to put 949 over times 100. So that's going to tell us what percentage we increased by. Remember, it's an increase of this population, you know. So 949,900 people out of this population would be what percentage increase? So that cancel. Yes. 35.
Yes, sir.
So there's a 35% increase in this population. So what's the other way you think we can do this? You think there's another way we can do this?
Sir, something with the years.
No. We can just put the two populations over each other. So since this represents 100% of the population, we should be able to put and this should give you 135%. So the increase, so since this is 100%, and we get 135%, the increase would be 35%. Similarly to what we did, what was it? Here, the 120% of that. Something like that. Alright, so last part of this question. So the ratio of teachers to male students to female students in a school is 3 to 17 to 18. If the total number of students in the school is 630, determine the number of teachers in the school. Alright, so firstly, this is a part whole to part ratio, or part to whole. So these parts could be added up to represent the entire population of students and teachers in that particular school. So the ratio of teachers to male students, so this 3 here, and it doesn't mean 3 teachers, you know, so don't get that twisted. It doesn't mean we have 3 teachers in the school, because I know someone is going to say that there are 3 teachers. So we need to find the total ratio. Well, not the total ratio, because total ratio of students. So the total ratio for the students would be what? So 17 parts here, so 18 parts here, so. So 30, 35. So the total ratio of students is 35. That doesn't mean we have 35 students, you know. 35 parts. So 17 parts out of this would represent the males, 18 parts would represent the females. So they told us that we have 630 students. And basically this 630 can be divided into 35. That's what they were telling us. So to find one part of the ratio, so one part is equal to 630 divided by 35, and that gives us
18.
So one part of this ratio represents 18 individuals. Go again. For what, the teachers? So the girls would be 18 times 18. 300 and what you said?
24.
Oh, and but they didn't want the girls, they want the number of teachers. So we know that the number of teachers represents 3 parts. So 3 parts represent teachers.
So,
Yes?
what does the 18 represent?
So 18 will represent one part of this ratio. So you see we have 3 to 17 to 18 over here, so each one part represent 18 people. So it's like being multiplied by 18 per se. So to get the number of girls, it will be 18 times 18, number of males, 17 times 18. So the number of teachers is going to be 3 times, yeah. So 3 part represent teachers. So 54 teachers.
Sir, could you cross multiply? And that's what I did.
Repeat.
I was asking if it's okay to cross multiply because that's what I did.
How you do that now? You said 3. You write that.
Sir, I did. No, sir. I added the number of and I said 3 equals 35, x equals 630, and then I cross multiply.
Oh, so you added the number of students here, so that'd be 3 teachers to 35 students overall, right?
Yes, sir.
Then you'll say x teachers to 630. This is very good, yeah. And you can cross multiply that, and you get your answer. So you can do it like this. Alright. So we have a few minutes left, and we want to look at the angles for Kai. You know, Kai put me and Mr. Crawford and I see him both. Alright. So Kai, you were asking about Z angles.
Yes.
Alright, so what we have here is parallel lines and its transversal intersection. So parallel lines and its transversal intersection. So these lines here are parallel to each other. So they are running in the same direction, same distance from each other, never meet, so on and so forth. This one is what we refer to as the transversal line. So it's a line that cuts through parallel lines. Now, once a line cuts through parallel lines, it's going to form 8 angles. So we can see those 8 angles, right? 1, 2, 3, 4, 5, 6, 7, 8. Correct?
Oh,
So we have 8 angles being formed once a line cuts through a parallel line. Now, there are many angle properties that we can identify from this. Many properties. So if we're looking at, let's say, the top part up here, we can identify angle on a straight line right here. We can see that, right? Angle on a straight line.
yes, sir.
We can also identify angle at a point. Angle at a point measures 360, so the entire angle up here will measure 360 degrees. Also, we have what we refer to as, so let me use it, I'm going to color code this. So what we have here and here is what we can refer to as vertically opposite angles. So vertically opposite angles, they are equal to each other. So if this is angle, should I use number? Let me use numbers. So let's say this is 120. This down here, 120. They are vertically opposite, so they are equal to each other. So if that is 120, what would this one be? What is it?
60.
60, because we have angles on a straight line. Angles on a straight line next to each other add up to 180 degrees. So if this is 60 now, what is this one?
60.
And what's the reason?
Because
And they're vertically opposite.
So,
they're equal.
so they are vertically opposite, as well as we could even say that they are angles on a straight line as well. Because see, straight line here going this way, you know. So see, straight line going that way, so we can identify these two angles on the straight line. So more than one properties can be used to identify an angle. That's fine. So now that we've established all the angles up in that section, we can now move down to this section. So if we should highlight this angle here, what would this angle be?
120.
And what's the reason?
It could be Z angles or opposing.
So this could be three things. So let me give this a letter. Let's call this angle E. Let's call this angle A. So if we're looking at it, angle E is corresponding with angle A. Remember that corresponding angles, they are equal as well. So corresponding angles are equal. So angle A is equal to angle E in this case. They are corresponding. So we've identified that we have a Z angle here. So you see the Z, Kai? Even though it don't look like the typical Z.
Yeah, I see it.
So that's why we get the 120. So let's call this one B. So we can say A and B, they are alternate interior angles. So A is equal to B, and the reason for that, alternate interior. So alternate interior, they are equal. So that's two property. What's the other property?
Exterior.
Exterior. Yes?
I was going to ask if the Z angles.
No, Z angles is alternate angles. So this is Z angle.
Okay, sir.
So the other property is co-interior. This one and this one, co-interior. And what do we know about co-interior angles?
They add up to
Add up to 180.
So they add up to 180. So they are co-interior. So now that we have that out of the way, what would this angle be right here?
60. Because angles in a straight line add up to 180.
And which other reason we could I use?
Alternate interior angles.
So we could I use alternate interior Z angle. So we see the 60 here, so come down the form with Z, we have the 60 here so as well. And which other rule?
Opposite. Vertically opposite.
No. In order to use the vertically opposite, we would need to know this one down here first. Go again?
corresponding angles.
Yeah, corresponding. So it's corresponding with the 60 up here. So you have angle on a straight line Z. So whichever property you want to give, it's fine. So now that we established that that is 60, we can know that this is 60 as well. Vertically opposite, angle on a straight line. And this one is alternate exterior. So let me give this one a label. So let's call this one so let's call this one C, and let's call this one F. So C and F, they are alternate exterior angles. So C is equal to F alternate alternate exterior. So they are found on the outer parts on the opposite sides. opposite side of the transversal. So this is the transversal line, and the angles are formed on the outside on the opposite part of the transversal. So that's why we get the alternate exterior. So the last angle here would be what?
120.
And we have so many different properties we could use for this one. We could use vertically opposite, angle on a straight line, alternate exterior, corresponding. So there are so many different properties we can use to highlight this. So once we have a set of parallel lines and it's transversal, there are multiple different properties that can come out from that one question. So Kai, I hope that clarified this for you.
Yes, sir. Thank you.
You're welcome. So we'll try and have one more session further down in the week. And this time I want to look at some construction, some statistics, and let's see what else we didn't really touch on. So construction, statistics, and maybe some transformation. 1 and 2 patterns thereabout. So we'll see what we can make happen down in this week. Alright, so I'm going to send, let me stop the recording.